Welcome dear students and friends to this channel. So today we are in the second lecture of the series Divide and Conquer Strategy, and specifically today we will cover maximum and minimum and linear search and binary search. So let us start. So first we will see finding maximum and minimum in a given array. So basically what is the problem in hand? That input is given an array of n elements and we are supposed to find maximum and minimum out of the n elements. So as an example, so the input array A is like this 10, 20, 30, 1, 2, 3, 11, 21, 31. So there are overall 9 elements and indexing is always applicable like 0, 1, 2 and so on so and up to 8. So 0 to 8 overall 9, and we are supposed to find maximum and minimum. So what is maximum in the entire array? So it is 31 and minimum is what? 1. So the question arises that how to solve this problem. So it is very an obvious problem. We can solve it with iterative procedure, means by using simple formula. Okay, by taking first element of the array as 10 as what minimum as well as maximum, and running a for loop from first index or second index and going to the end. And if we get a value maximum to our previous maximum, so then we will update. Otherwise if minimum to the our previous assumed minimum, then we will also update. Okay, otherwise leave it as it is. So let us see the actual implementation. So this is without divide and conquer. First of all, straight maximum means without divide and conquer strategy. So this A is given. So this is what? Array. So this A is array, and this N is what? Size of array, and max and min is what? Finding maximum and minimum. So initially what I am assuming here, maximum and minimum taking as the first element of array. So in our case, so what will be the first element? So the first element will be like this. Let us 10, 20, 30, 1, 2, 3, 11, 21 and 31. So starting from like 1, 2, 3, 4, I am assuming these are the indexes. Okay, indices 7, 8 and this is suppose 9. So initially maximum and minimum I am taking as the first element. So what is first element? Is 10. So initially 10 as minimum as well as maximum. Starting from loop is starting from what? Value 2 till n. N is what? In our case 9. So 2 to 9 the loop will run, and each and every time it will check whether जो upcoming value है वो अगर maximum से हमारे maximum से greater है तो maximum को हम update कर देंगे. Okay, otherwise हम minimum को update करेंगे. So I think this statement is wrong. So in this place max equals to a of I. Now it is correct. Okay, so in our case what will happen, like for 2 maximum is what? 20. So this will change to 20, and for 30 like this, and next time loop will run. So minimum you will get it as 1, and similarly maximum you will get it as 30. So at last, after the successful execution of this loop, you will get what? Maximum as 31 and minimum as 1. Okay, and finally returning maximum and minimum. So what will be the return value? Return value is what? Your maximum as 31 and minimum as what? 1. Okay, so I hope that this is clear. Very much no, obvious concept. Okay, running a simple for loop and checking whether each and every element of the array is maximum to a particular element or minimum to a particular element, then there is a need to update. Otherwise no need of any kind of updation. Okay, so if you observe carefully that this is a simple for loop and it will take n time, order of n time, because this loop is going to run n minus 1 times because it's starting from 2. So that's why it will take n order of n time. So let Tn be the number of comparison required to find maximum and minimum in the given array of n elements. So what will be the time complexity? So the time complexity in this case is in best case, so it is also order of n, it is also omega of n, and in worst case also it is order of n. So that's why we can say it can be represented as theta of n. So this is the time complexity. Okay, so time complexity without divide and conquer. Okay, solving minimum and maximum without divide and conquer strategy. So this is the general approach. But now we will see that if we are going to solve this particular problem of to find maximum and minimum with the use of divide and conquer strategy, then maybe there is some impact or not. Let us analyze that also. Okay, so this is divide and conquer strategy. So what we are doing, firstly, this I is the initial index and j is the last index. So this I is what? Starting index. So it is the starting index, and this j is what? J is the last index of the array. Last index of the array. Okay, so initially we are taking as mid as an element, okay, as an integer element. And if I double equal to j, first condition, if I double equal to j, so this says that that your array is having only one element, so that is maximum as well as minimum. So max min will be updated as a of I, and simply returning to that maximum and minimum. So this is quite obvious, है ना? This is a constant. Okay, this is only one comparison there. Now this else part, come to this else. If I equals to j minus 1, so what is that? That I equals to j minus 1 means it is having two elements. Okay, so I equal to j minus 1 means this is the case of array is having only one element, like this. And this is the case of array is having, let us suppose, two elements like 10 and 20. So in this case, this is 1, this is 2. So I is 1, j is 2. So 2 minus 1 is 1. So it means this array is having two elements. So if a of I is less than a of j, means a of I वाला minimum है ना, और a of j वाला maximum है. तो max में क्या store करेंगे? A of j, और min में store करेंगे a of I. Okay. Otherwise, अगर ये condition false है, then that means that a of I is maximum and a of j is minimum. So maximum में a of I and minimum में a of j. So this is quite obvious, है ना? It is quite obvious. Means this is for zero element, or this is for one element in array. One element, and this is for two elements in array. For two elements in array. For two elements in array. Okay, now come to the major part. Okay, this is divide and conquer, means it is always a recursive program. So these are some initial conditions. There are multiple initial conditions, that's why two initial conditions, है ना? Now come to actual else part. If the array is having what more number of elements, okay, more than two elements are there, so maybe some 10 or 100 or 1000 elements are there. So then how to find minimum and maximum? So in this case, firstly find mid. So how to find mid? I plus j, starting index plus last index, divided by 2. So this will give you the mid element, middle of the, no? And again apply the same approach to what? To mid, I to mid, starting to mid, divide and conquer we are calling. Okay, I to mid. And next time divide and conquer maximum we are calling from mid plus 1 to j, means mid plus 1 means mid to next element, and up to the last element. So these two statements will work, and again this function will be called. And after coming out from this, so max 1 and min 1 and max 2 and min 2. So we are checking whether max 1 is less than max 2. So maximum क्या हो जाएगा? Max 2. This will be there. And else अगर ये condition false है तो max 1 will be greater. That means max equals to max 1. This. और if अब min को भी compare करना है, both mins are there, min 1 and min 2. So if min 1 is greater than min 2, that means minimum is min 2. So minimum is going to be min 2, else minimum is going to be minimum. Okay, min 1. And finally returning maximum and minimum. So this is the divide and conquer approach. Okay, now we are analyzing that number of comparison. Let us suppose Tn is the number of comparisons which are required to find the maximum and minimum from the given array using divide and conquer approach. So for one element, if n equals to 1, only one comparison is required. Okay, this is clearly observable from there. Okay, this is for one element. So how many comparison? One comparison. and this is the case for two elements. So two element, how many comparison? There are two comparisons are required. Okay, so let us see this. Okay, so here it is no comparison and here it is one comparison. Inside we are comparing one time. So if n equal to 1 means only one element is there, so zero comparison. And n equal to 2 means two elements are there in the array, then there is what, one comparison. And otherwise we are dividing the problem into two halves. That is 2 is the number of sub problem t n by 2 n by 2, because we are what dividing the entire array into two halves, and plus 2 means these two comparisons. So this is the one comparison and this is another one comparison. So these two comparisons are also required after this 2t n by 2. So finally, if we solve this particular problem, so what will we get? Like t of n equals to 2 times t of n by 2 and plus 2. So let us suppose solve this particular thing with substitution method. So 2 into t of n by 2, if you replace, so it is n by 2 square, and what, plus 2 is already there, and so this is the substitution part. Okay, so now what will be the answer final? 2 raised to the power 2 t of n by 2 raised to the power 2 plus this 2 will be multiplied with this 2, so 2 raised to the power 2 means 4, and plus this 2, so 2 raised to the power 1. Now see one more term, so 2 raised to the power 2, and here overall substitution part will come, and plus 2 raised to the power 2 as it is, and plus 2 raised to the power 1 as it is. So now substitute t of n by 2 square. So what will you get? So it is 2 into t of n by 2 square. So if you put n by 2 square, so what will you get? N by 2 of n by 2 square means n by 2 raised to the power 3. And plus here it is what? Here it is 2 already. So now according to this, multiply this 2 square inside. So 2 raised to the power 3 into t of n divided by 2 raised to the power 3, and it is plus 2 into 2 raised to the power 2 is going to be 2 raised to the power 3 plus 2 raised to power 2 plus 2 raised to power 1. Okay, so finally we are going to what, n equals to 1. So n equals to 1 means, let us suppose if I repeat the same process k times, so what will happen in that case? K times, so this will reaches to 2 raised to the power k into t of n by 2 raised to the power k, and finally this value will become 1. Okay, and plus, so this 3 3, so here 1 2 3, so now what will happen? So here 2 raised to the power k up till 2 raised to the power k, and so on so forth, like 2 raised to the power k minus 1, and so finally 2 raised to the power 1. So if you observe carefully, then this is what, this is GP, geometric complex. This is a GP. So what is the sum of uh, n terms of GP? If your common ratio R is going to be greater than 1, so it is what, A into R raised to the power n minus 1 divided by R minus 1. So don't worry, I will solve it. So what will be the relationship with this? So it is n upon 2 raised to the power k equals to 1, and finally from here you will get k equals to log n base 2, like this. Okay, and solving this, let us solve here. So you will get it as 2 raised to the power k is going to be n into t of what, 1. Okay, and plus termination condition means you can take either n equal to 2 or n equal to 1, whatever, है ना? So it is from 2 raised to the power 1, 2 raised to the power 2 till 2 raised to the power, it is k. So this way you will get n multiplied with 0. T of 1 is what, 0, and plus, so this is a is 2 into r is what, 2 raised to the power number of terms, so there are k terms, 2 raised to the power k minus 1 divided by r minus 1, so it is 2 minus 1. So finally this way you will get what, 2 into 2 raised to the power k value is going to be n, so it is n minus 1 and divided by it is 1. So finally 2n minus 1, and which is nothing but order of what? Order of. So this is the time complexity. Okay, so this is the time complexity of what? Finding maximum and minimum with the use of divide and conquer strategy. Okay, with the help of divide and conquer technique. Okay, so it is very much observable that in previous case without divide and conquer strategy is also taking order of n time. Okay, and this divide and conquer strategy is also taking order of n time. So this is the time complexity. So if both the algorithms are having same time complexity, then we will move for space complexity. So we will see how much space. So obviously divide and conquer strategy will take what? More space as compared to iterative program, because it is recursive in nature, divide and conquer. So divide and conquer max min find algorithm will take more space as compared to the iterative max min finding algorithm. So that's why, so in order to find the maximum and minimum in a given array, the ultimate or best approach is what? Iterative method. Okay, so finally this is the concluding remark, that both algorithm will take order of n time. So obvious, because of both will take same time, we have to go for what? Space. So divide and conquer, okay, maximum takes what? More space. Divide and conquer maximum takes more space. Obviously it is a recursive program. So that's why ultimately we can say, what is the conclusion? Without using divide and conquer is better approach. For what? For maximum. For maximum. Okay. So this way we concluded that finding maximum and minimum is better if we simply use the iterative algorithm. Okay. Okay. So this is the maximum. Now come to the searching. So what is searching? Searching is quite obvious in your computer terminology or in computer science. And searching refers to that you are given an array of n elements, or some sort of elements are given. Let us assume n elements are given and one more element is given which we need to search. Okay, and if the element that we need to search is present in the array or present in the list, then we are supposed to provide the index of that element. Otherwise, if it is not present, means unsuccessful search, so then return what? -1. It is the simple concept, very basic concept. So understand very carefully. So input is given an array of an element and an element x that is to be searched. Okay, and output is what? Return position of x if x present. अगर x वहां है so position उसका, otherwise return -1. So -1 means it is unsuccessful search. Unsuccessful search. And this is what? This is successful search. This is successful search. Okay, so as an example, take this, that array elements are given 10, 20, 30, 1, 2, 3, 11, 21, 31, and the element to be searched is what? 11. So what will be the output in that case? So 11 is at what? Let us suppose this is 1, this is 2, this is 3. Indexing it may be any, from starting from 0 if we are going for actual implementation like C and C++ programming, and some other programming, or otherwise wherever the indexes start. Okay, so 4, 5, 6, 7, 8 and 9. So finally 11 is at 7th index, so finally the output will be 7. Okay, this, like this. Okay, so 7 for what? For x equals to 11. And -1 if we are searching for an element that is not there inside, means for example let us suppose 40 you are searching, so then you will get what? -1. So this is successful event, and this is unsuccessful event. Okay, so this is successful event and this is unsuccessful. So I hope that this is clear. So it is very simple concept of searching, that you are given a list of an element and a single element which we need to search, and if that element is present which we are supposed to search, that element is present in the list or in the array, then we are supposed to return the address or that location of that element, otherwise return -1 in case of unsuccessful event. Okay, so let us take the linear search. So linear search is quite simple and it is just a single for loop. So A is given, A is what? Array. So this is what? This is array, and this is size, and this X is element to be searched. Element to be searched. Okay, linear means one by one, sequential search. So what is sequential search? So starting from I, we are taking as integer I equals to 1 to n up to n, because elements are n elements are there in the list or array. So if a of I double equals to x, because we are coming from first, second, third and fourth. So if any element matches to x, then return that index, otherwise return what? Minus. So after, okay, if the loop is returning from here only, that means successful event. So this is called successful search. Successful search. And this indicates that unsuccessful event. Unsuccessful search. Okay, and very important point, that this particular algorithm, time complexity of this algorithm, it is quite obvious that it will take what? Order of n time, because it is running n times. Okay, so the time complexity, for this algorithm is going to be order of n. Okay, for linear search. Now one more interesting, two kinds of searching are there, linear as well as binary. So if I'm talking about linear. Okay, linear search. So in case of linear search, array applicable. So this linear search is applicable if array is sorted or unsorted. Sorted or unsorted. So what is the meaning of sorted? Sorted means the elements of the array are in some specific order, whether they are in ascending order or whether they are in descending order. Okay, but in case of binary search, if we are applying binary search, so in case of binary search, it is applicable only in sorted array. Only in sorted array. Okay, only in sorted array. So I will show you what is the meaning of binary search. So everyone has gone through the searching of a particular English word in an English dictionary. Okay, in not in the soft copy format. I am saying that is a hard copy of what English dictionary. So in that case, what will happen? Suppose you want to search a particular word, so then simply you may go to middle of that element, because you know all the pages or all the text whatever written in the dictionary are in sorted order from alphabetically A to Z. Let us suppose you want to find what? The word pink, whether it is available or not, successful or not. Searching, you are searching the word pink. So just go to the middle of that element or middle of that dictionary, or middle of that dictionary. Let us suppose it is what? It is J. Okay, and you are searching P. So half of the element you eliminated, because you know that if J is there, then I have to support next time what? Right half of that particular dictionary. So left half has gone. Now remaining part, on the remaining part again you apply the same concept, binary search. So just open the middle of the remaining, then again do the same process until you reaches to your required word. Okay, so this is the simple dictionary search or binary search. So it is only applicable if the array is sorted, okay, in nature. So binary search. Now let us come to the actual concept, binary search. So what is binary search? So binary search, first of all, it is input, and what is the input and output? So input, a sorted array of an element, always a sorted array. Okay, it is clearly written that sorted array. Okay, of an element, and the element x which we need to search. So return position of x if x is present. So this is what? Successful case, successful search, and otherwise return what? -1. So this is the case of unsuccessful search. Unsuccessful search. Okay, So successful search and unsuccessful search. Let us suppose this is the array, and we need to search x equal to 40. So what will be the output in that case? Output will be, let us suppose indexes are 1, 2, 3 and 4 and 5, 6 and 7. So in this case 4 will be the answer, because 4 and for what, for we are searching x equal to 40, and it will return what, -1 if we search some element which is not there. Let us suppose x equal to 15. So this is successful event and this is unsuccessful. So I hope that you are getting this point, that binary search is always applicable on sorted element. And so see, this array is in sorted order, means ascending order, whether it is ascending or descending, okay, increasing or decreasing. So the elements are in increasing order, 10, 20, 30, 40, 50. The general meaning of sorting is what? An ascending order by default. Okay. So now let us actually implement this particular problem, okay, with using divide and conquer strategy. So this is the array. So this A is what? It is array. Starting index, start index. This is the end index, last index. This is going to be the last index, and this, what is this x? This x is the element to be searched. Element to be searched. Okay. So firstly take mid, and this is the initial condition. This particular point is going to be the initial condition, that if I double equal to j means only one element is there in the array. So then one element is there, so check whether that element is your element or not. If it is your element, then return the index, means whether return I or j, whatever your choice, and otherwise return -1. So if a of I double equals to x, then return I or j, whatever, because only one element is there. Or if it is not your element, then return what, -1. So this is a simple, only one comparison is required. Now come to else part. Else part is interesting one. So what we are supposed to do, I already taken the example of what, dictionary. So firstly find the middle of that element, middle of that array. So how to calculate? You know starting address, you know ending address, just add it and divide by 2. So this way you will get the middle element. This way you will get the middle of array. Okay, and if middle of array is your x, then okay, it is fine, then return mid, simple search. Okay, otherwise it may be your element x is greater than the mid, element available on the mid, so then you need to you need to search on right side, otherwise you need to search on left side. Okay, so else if mid element at mid, okay, element at mid is greater than your x, okay, that means you have to search was left side. Left side mean binary search again apply, starting index is same and last index will be mid -1, because आपको लेफ्ट साइड में सर्च करना है, तो इट इज मिड -1. ओके, और अदरवाइज अगर आपका एलिमेंट जो है वो ग्रेटर है, दैट मीन्स यू नीड टू सर्च व्हाट, राइट साइड ऑफ द एरे. ओके, सो बाइनरी सर्च आप अप्लाई करेंगे, स्टार्टिंग इंडेक्स चेंज हो जाएगा, मिड +1, लास्ट इंडेक्स +1. So okay, any one condition will apply, any one will apply. So it is any one call will be there, any one call will be there. Okay, because it is if and else condition. So this is the end of this particular else, and this is the end of previous else, and this is the end of program or algorithm. Okay, now let us see what is the amount of time or time complexity of this particular binary search. So let us take, let Tn be the amount of time required to find position x in the given array, okay, given array of n elements, okay, using binary search. So if n equal to 1, now I am talking about actual time complexity. So if n equal to 1 means only one element is there, so simply just check whether it is my element or not. So constant time is required, that's why if n equal to 1, then only c, constant time is required. Or otherwise n is greater than 1 means more than one elements are there, then only 1/2 is required, means 1/2 means either you will go to left or you will go to right, so any one. So t of n by 2, and plus c means some sort of comparison, some sort of calculating the middle, some almost negligible time. So that is some constant time. Now solve this particular recurrence relation, so you will get the required answer. So what is the recurrence relation? Recurrence relation for the binary search is what? T of n equals to T of n by 2 and plus c, some constant times c. Now apply the substitution method. So it is plus c is already there. So if you apply T of n by 2 in place of T of n, so this will become T of n by 4 and plus c. So T of n by 4 and plus c. So this is nothing but T of n by 2 square and plus c, and plus c is going to be 2c. Now again substitute one more time. So this is the substitution part and this is the previous part, 2c. So T of n by 4, if you substitute in place of n, so n by 2 divided by n by 4. So this will be n by 2 raised to the power 3 is n by 8 plus c. So this will gives you T of n by 2 raised to the power 3 plus 3c. So this way you will approach and till let us assume k times. Okay. So I am solving here what I am writing. So like this part. So and finally this will become what? T of n by 2 raised to the power k, and this will become to 1 and plus what? K times, so 1 time 1c, 2 times 2c, and k times what? Kc. So finally solve this. So this you will get n y 2 raised to the power k equals to 1. So 2 raised to the power k equals to n. So taking log. So if you take both side log on base 2, so 2 raised to the power k equals to log 2n. This will become here we apply formula log m raised to the power n is going to be n log m. Okay, so you will get k into log 2 base 2 equals to log n base 2. So this, now finally I am applying that log a base a. So the value of this is what? This is 1. So this will return as k into 1. So k equals to log base 2n. So this is our required thing. So finally this will gives you t of 1 and plus this kc. So what is the value of k? K is log 1. So this is c into log n base 2. And what is the value of t of 1? See in the previous t of 1. So if n equal to 1, then it is c. So this will return you what? C plus c log n base 2. So what is the maximum term in this particular expression? So the time complexity. So the time complexity of binary search is going to be what? Order of log, like this. This is the time complexity. Okay. So this is the binary search, and I hope that these concepts are clear to you people. So today in this lecture I covered two interesting concepts. So basically the very first one is minimum and maximum of an array, finding minimum and maximum of an array. And we saw that if we solve the maximum and finding minimum and maximum of an array without using divide and conquer and with using divide and conquer, so almost they are taking same time. So time complexity is same. But if we talk about the space, so the space required in divide and conquer technique is more as compared to iterative approach. That's why to find maximum and minimum of an given array, the best approach is what? Without divide and conquer. Okay. And the next concept which we saw is what? Searching. Searching is interesting thing that you are given n elements and a key which we need to search, and we are supposed to return the index of that element if it is successful search, otherwise -1. Okay. So finally at the searching algorithm we saw two kinds of searching: linear search as well as binary search. So linear search is applicable whether the list is sorted or unsorted in any case. Okay. And binary search is only applicable if the list is in sorted order. Okay. So keep this is in mind. And the time complexity for the linear search is order of n, and the time complexity for the binary search is order of log n. Okay. So now finally we are at the end of this lecture. And if you have any doubt, then write in the comment box of this particular video. So happy learning to all of you. Stay safe.